Hey everybody. Sorry for the delay in getting things ready today. It's it's just been it's been a long and hectic day. A good day. I'm having fun. I'm doing good and everything's good, but it's just been just a lot to do. Um, which is okay. It's nice to have plenty to do. So let's get started here. Get everything kind of plugged in. Print. Print. Okay. I'm going to give folks a second to kind of trickle in here. All right. Cool. Thanks. I am doing well. um, yeah, I ended up taking study hall today from Tovio, who's busy with some other work, um, and just asked me to cover. So um, it was a slightly short notice, but I mean that's okay. Like it's just one of those things. We're getting into the busy part of the season, so it's actually a good sign that I'm getting busy this early in the cycle. Means we looks like we're going to have a lot of applicants, so that's great. Um, yeah, so it looks like we are starting off with a question today, which is really good. And I'm just going to copy this in. Okay, and we've got some non-ASCII characters in here. Um, I don't know if you all can tell, but these little devils are not actually quote marks. Sometimes this happens when copying and pasting from Slack or other rendered like sources. I mean, it's fine, but if I tried to run this with these quote marks like this, I'd get errors. Let's see what error I actually get. It's just an invalid syntax error. It says invalid character in identifier. So that's a weird one because it's not a thing you see a lot, and you can see it's pointing at that um, quote mark there. So replace those with standard ASCII quotes. So those are, if you're curious, those are non-Unicode quotes, which is a really weird thing, but cool. Oops. I'll just do this and this and this. Okay, so let's see what the nature of this question is. Can we go over the vowel question from yesterday? Sure. Um, oh, that's just the same code. Okay, good. So this is a question from a breakout that we do in Premium Prep. And let's look at this. Given the following list of letters, create a function that goes through each letter and prints the letters if it's a vowel. So I gave some odd instruction on this, and that's on me because I was saying, remember, I think I said at one point, like, remember, you don't generally want to print inside of your functions, which is true. However, this problem statement happens to ask specifically for printing. So I think I'm probably going to go back and rewrite this question so that you accumulate a list of characters. Um, so in this case, what's going to happen? This code as it's written, let's just run this. So we have a char list. You're defining a function, takes in a variable, or excuse me, it takes in a parameter, which is going to be a list of characters to go through. Going through the characters, checking if the character is a vowel, so if ch in vowels, and then returning true. So this problem statement doesn't actually ask for a return. I did mention in Premium Prep, I said, make sure it has a return, and then I tried to correct myself a few seconds after that and say, oh, I'm sorry, this is actually asking for you to just print off the character if it's a vowel. So as this question was stated, um, it's asking you to do something like this. ORCHID. So you want to print off the O and the I. So in this case, it's just meant to print off the value. That's as this was stated. Now, probably how I'm going to rewrite this is to say something like, given uh, any list of let's say this, given any string or list of letters, create a function that goes through each letter and accumulates that letter, I'll say that letter, if it accumulates that letter into a list if that letter is a vowel. Cool. Not sure if you can hear my screen reader. Oops. Apologies. 1 second. Okay. In general, you will write functions that have this pattern to them. In that they'll take in a value and often accumulate inside of them onto a list or something else and return that value instead of printing something off. So instead of printing, this is where I'm going to do the accumulation. I'm going to say list.append ch, if ch is a vowel, and then I'm going to return list. So this is something that's maybe a little more like real life, in that you have a function with an accumulator pattern, and then we're returning a value instead of printing off inside the function. And then it changes what we see in the console here, but it's still basically the same thing. Well, hopefully that's clear. Not sure exactly. I hope I didn't miss your question. Yeah, I don't know. Let me know if that's helpful, or if you have a specific question, or if you just want me to go through it again and explain it step by step. happy to do any of that. Floor is open for questions. To anybody, if you've got a question, feel free to pop it in there. Yeah, okay, so we've got a response. So yes, that helps. So if we use return instead, we will need to print at the end. Yeah, so if you use return in your function, which I'm just going to go ahead and say you should in most cases, most meaning like almost all cases, almost any time you're writing a function, that function is going to take at least one argument and return something. There are exceptions to that. All parameters are technically optional, or having a function with parameters is optional, technically. Returning is optional, technically, although unless you're doing something really specific or and kind of weird, most of the time you're going to have at least one input and an output. And because of that, you'll print where you call, right? So I call the function and I stick that in a print, and that'll just show me whatever it's returning. So yeah, so you'll still need to print. If I left this off for whatever reason, then I just don't see anything. I assure you that the code did run, but we're just not seeing anything because we're not telling Python to show us anything. So yeah, you'll still need to print at the end like that. Cool. Awesome. All right. I'm going to give you all a minute just to get in any questions that you might have. And if I don't see anything, then we will jump into some of the material. All right, cool. Let's jump into some of the material. I've talked about variable scope the last couple times. I feel like maybe I'll just give this a quick once over. That's important enough to emphasize. Go over it a few times. Variable scope. So variable scope refers to when and where a variable is accessible relative to where it was created. So we talk about scopes we talk about scopes in terms of global scope and local scope. So if something is in the global scope, everything has access to it. If something is in the local scope, it's only accessible within that local scope. local scope for the purposes of this discussion is the scope created within a function. Um, so functions have their own local scope. Classes also have their own local scope as well, although I don't get that deep into classes. Our material doesn't get that deep into it, and we don't get into it in Premium Prep much. I do have a lecture prepared that we actually dropped from Premium Prep, which I might give in study hall if there is interest in it. And I'll probably ask people if they want to see that, and you can let me know later. Cool, so let's just create a variable. This is going to be in the global scope, x equals 10. Obviously, I can just print this out because it's here. Great. Let's define a function, and we'll say def my function takes in a, well, I'll just say it takes in a variable. I can access x inside my function. Now, this is something you can do. It is something I'm going to go ahead and say that you shouldn't do ever under any circumstance. Even though Python will allow you to do it, I personally would prefer that Python would tell you, no, don't do that, that's an error, I'm not going to let you do that. There are other languages that I work in where this particular behavior, accessing a variable from the global scope in your function is just prohibited. You can't do it. And I prefer that. But Python lets you do it, even though you shouldn't ever. Um, you might think, well, that's a powerful thing. I can access variables in my function. Like, wouldn't I want to do that? And like, variables hold information, they hold data. You want to be able to like process that data, and the process in which you process that data probably happens inside of a function. So they have to find their way into your function eventually, but they should not find their way into your function this particular way, in this particular manner, right? So if I have a global variable and it finds its way into my function, it has to come in through the parameter. If I don't have enough parameters, then I should probably add some, you know. It shouldn't just show up without either being created inside the function or being a parameter. But a variable that is created in the global scope, let me try that again. A variable that's created in the global scope um, shouldn't just show up in your function randomly. The only two ways that you should be using variables in your function is, you can use the parameters. You can take a global variable, and when you call the function, you can pass it in as a parameter. That's acceptable. That's totally fine. And I'll show you that. You might think, well, what's the difference? Like if I pass it in as a parameter versus if I just use it, how is that different? And I'll give you an example of that. Also, if you create a variable in the function, you can use it in the function, but you can't use it out of the function, right? So if I do, let's just create y equals 20. Print y. If I try to print y outside the function, it'll give me a problem. I'll actually do that in a different example. Let me try to section this off. So using a global variable in a function. It's valid. Valid meaning that like it's valid code. Python won't stop you from doing it. So that's what I mean by valid. but it's forbidden. I forbid you to do this. I do. I'm serious. If you send me code, I'll be nice about it. I always try to be nice about it, but um, if you send me code and you have a function and you're just using a global variable, it's the first thing that I will address. I'll be like, okay, let's find a different way to do this because that's not, I'm not gonna, I'm not gonna let that fly. Okay, so okay, so I create the global variable, print it off. Obviously, that's gonna work fine. I have to invoke the function in order to run the code within it. All it does is just print off that global variable. So that's gonna work, but I'll show you why you don't want to do this. Let's say, I think I gave the same example. Let's say add 10, right? So if I return a plus x, and I'm just using x for 10, if in other words, obviously, like, I should write this function like this. Why wouldn't I do that? But in other words, and I want to just give a simple example of this without too much code in the way so that you can kind of see everything. Even though this is a clearly silly way to write this function where I obviously don't need to rely on x, if I write a function that uses a global variable and I rely on that global variable, which I do if I'm using it anywhere, the output of my function is reliant on it somehow. If it changes, it would change how my function works, right? So if I just use it, and let's say we'll add 5 to 10, and we'll get 15. Great. This is fine. Everything appears to be fine, which is part of the issue. If I just say x equals 100, so I just changed how my function works, and it changes it forever. It's permanently adding 100, right? And you might think, well, that's kind of a nice feature, like, I fear that by showing you this, you think, oh, well, that I could use that, because I have this thing called x, and I could like configure this function by changing this variable. There are other ways to do that. You can do that, let's say add num, and let's just say num. So I could just take in another number. I'll call it num, and I could just default it to say 10, right? So now it'll add 10 by default, and x isn't gonna, x isn't going to, oh, what am I doing? X is not going to influence the outcome. So now I have something that takes in one argument, and if I want to change the configuration of a given function call, I can say num equals 100. Why not? Or I can just pass 100, right? So essentially what I've done is I've said, sometimes I might want to just pass one argument and make the assumption that num is going to handle that. But under certain circumstances, I might want to change the value of num, kind of reconfigure how this function is going to work. But I only want to reconfigure it on a call-by-call basis. If I reconfigure the function with a variable, especially one that is named like something common, like x or something, something like that, uh, then it's not really clear. Like somebody else, myself or somebody else could come along and just name a variable this, and it would just break the function or just change how it works. And hopefully it's clear that that's not desirable behavior. You don't want to just like, make a new variable and then just you've ruined a function that your code is reliant on, right? So if you want, if I really wanted x inside my function for whatever reason, I can just pass it. I can just say, I can just pass x to my function. So I can add sort of defaulted configuration information into my function head that I have to pass configuration information every time if I want to change those defaults. That way I get a nice easy interface for the times I just want this to add 10, and then if I want it to add something else, I have to like supply other information. Maybe it feels like, oh, well, I have to do it every time I call the function if I want it to be something other than 10. If I want that configuration information to be something different. But it means that like you end up with something that's more in your control and less, it's not just reliant on some outside value, right? So that's really the big takeaway here with uh, global variables, is that you want them to you want to use them in your functions via the parameters only. You don't want to use them via just like using them in your function. If you have a global variable, it can come into your function as a parameter, but not just be in there randomly. Okay, let's do the challenges. I promise I'm done talking about global variables. Um, yeah, okay, so what will the following code print to your console? Location, Spain, find location, location France, return location. Um, this doesn't matter. So in this case, we have this parameter location and this variable location and this local variable location. So we have a global variable, a parameter, and a local variable. And then we return it, right? So what happens here is the local variable overrides the parameter, and the parameter would override the global variable. It kind of makes it additionally interesting because we have the global variable being passed to the function. So we're actually passing Spain to the function, which is legitimate. That's the right way to do it. We can pass it in there. And then since we have a parameter called location, we don't have a way to even access the variable called location because it'll just default to the parameter. But we just override that parameter with a different value with France, right? So what this is going to print is it's going to print the result. It's going to print whatever we return. We're returning the last known value of location local to the function, which is France. So this will be France. And then we'll return Spain. So this should see France and then Spain. What will the following code print to the console? Okay, now this is a weird one. We've got a function defined inside of another function, which is, again, that's something that you can do, and there are paradigms of programming where you'll do stuff like that. Again, I don't cover that, but something you might see. um, so obfuscation station, mysterious inner function. So this returns whatever mysterious inner function returns times 10. Mysterious inner function uses x, which is a global variable. This is all legal code. So x plus 5 is 2 plus 5. 2 plus 5 is 7. 10 times 7 is 70, We call that function, so that function returns 70. Okay, we got a similar thing here. Obfuscation station, mysterious inner function sets a variable that is local to this function, but global, kind of global, or it's global to this function. This function takes in an argument that it calls x as well. So when we return 10 over x, we're returning 10 over whatever we passed into this function. So I look for a call to this function. It's right here. We're passing 2. So x is 2. 10 over 2 is 5. It's going to be 5.0. So doubly mysterious, this returns 5.0. This x is just a false thing, right? So this returns what that returns. That returns 5.0. 10 times 5.0 is going to be 50.0. Since we're multiplying an int and a float, if we have two floats or an int and float or float and int, we get a float. The only time we get an int is when we do math with an int and an int. All right, scalar types overview. So scalar types are immutable, and they only hold a single value at a time. This is going to cover integers. This is going to get into integers and floating point numbers and booleans and strings and the none type, which are our scalar types. I'm feeling like doing a little bit of a pivot and maybe doing some code wars. Let's just pick a code wars problem. So if you're not familiar with code wars, this is just a coding practice website. We're not affiliated with them or anything. I just have experience using this. There's a lot of really good coding practice websites out there. So Tovio and I have both used Code Wars pretty extensively, so often we're pulling problems from here. So if we come into Kata, so when you sign in, it's probably going to take you to this dashboard, and then you'll come down here, and I always like to go to the search. It says Kata, and then you have the option to choose your difficulty. The difficulties are probably backwards from what you think they are. The 1s and 2s are really, really hard, and the 8s and 7s are the easiest ones, and 6s. So let's just pull from some easy problems. Nth order summation, that might be interesting. Last non-zero digit, oh yeah, he's working on that one with somebody. That's a weird one. Moves in squared strings for, that might be interesting. Count the divisors of a number. Ooh. Cool. So just based on the title of this one, I kind of have a sense of what it's going to do. Yeah, and it looks like this is right. So we've got to figure out what the divisors are and just return how many divisors there are. So as usual, I'm going to pull these into a doc string, and we're going to turn these into tests. Probably they're all written here though. I like, this is kind of related to the prime problems. I like these problems. They're fun. I'm just going to do this. So if you don't know what I just did here, I'm just trying to steal all the tests I can and build up as many tests as I can, because why the heck not? So, yeah. I think what I'm going to do, actually, these are all meant to be the expectations. X equals that. And this will be, I'm going to call this res, will be that. And then this here, we will print res equal to exp, comma, res. We'll do that. And I'm calling this res for result, which will be the result of my function. Let me just get a quick function stub, def divisors. We'll take in n. I'm just going to throw in a pass real quick. Get rid of these examples. I haven't even read the problem statement yet. Okay, let's just see if there's any redundant numbers here. So this one's testing for 4, this one's testing for 4, we'll get rid of that. This is testing for 5, and that's 5. 12, that one's testing for 12, that one's testing for 30. So we've just got these two, and I'm going to do the same thing with this. And we'll say this res, or exp. Exp is short for expectation. Res is short for result. I don't know if I said that already. I think I did. Aren't we doing 1 up there? Okay. We'll do 1 up here. 1, 4, 5, 12, 30, 40, 96. Interesting. Wow. So what I want to see, now I'm going to just, now I have all these tests, I'm just going to run my code and I should get falses and nones, right? So I had that comma there, I managed to catch it this time, but I'm just going to make sure that, I don't get something like this where it's like none, comma, something out of place, because that could throw off my tests. So falses and nones, that tells me I've got good tests, I'm not working, I don't, like I didn't do anything weird like forget a parenthesis or have a comma, just some random place, or whatever. So now I have 1, 2, 3, 4, 5, 6, 6 different tests, which is probably way more than I need for this, but that's okay. So count the number of divisors of positive integers n. Random tests goes up to n equals 500,000. Okay, so we might need to do a little optimization to this, but we'll see. So basically what I'm going to do, I'm going to return the length of a list, and I'm going to say list equals an empty list, and I'm going to append every time I find a divisor of n. So I just have to go search through a body of numbers to go find divisors. I'm going to say for I in range. We don't want to do 0, and we do want to include n. We'll start at 1, we'll go up to and including n. So let's see, if n mod I equals 0, list.append I. So let's just see if this passes my tests. True, 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 false. Ooh, Interesting. Very interesting. I wonder, okay, so I've got a fail. I wonder, um, did I mess this up in some way? Yes, I did. I messed that up. So that's expecting 13, not 3. So I screwed that up somehow. So that says true. Okay, so that is passing all my tests. True, 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 true. Okay, good. So let's see if this is going to work for this. I have a feeling it'll time out. We'll see. Oh, no. I thought I was going to have to do some optimization. I'm a little bit disappointed. I was like, oh, I want to do some optimization. Let's just do some optimization anyways. I didn't realize how much I wanted to do it until now. Okay. Um, so one thing we could do in true Code Wars fashion. So one thing I want to pause before I continue on with the optimization talk because, and I do this like every time before I write a comprehension, like I give this little disclaimer. Basically, if I asked you to solve this problem for me, if we were working together, um, this solution's great, right? If this is the kind of code that you can write code that works. That's like 98% of the battle. Um, Optimizing things can be really important. What I tend to emphasize is just produce working code. Don't worry about making it perfect. Just try to make it work. Um, that's the primary thing. So you can always take a working solution if it's not as elegant or not as nice or not as fast as you want it. You can always take a working solution and optimize it. So um, let's practice that a little bit. And again, you don't have to do this. I mean, I certainly won't make you, but it's if you want a little challenge, it can be fun. Okay, cool. So I'm going to turn this into a comprehension, and you can see I'm kind of making my code kind of weird here. So what I like to do when I'm turning a loop into a comprehension, I will break things open, and then I'll take my thing I'm appending, and I have a line move shortcut. Um, if you want to know the shortcut, it's I won't tell you mine because it probably won't work for you because I customize all my shortcuts. Um, oh, actually, no, I customized this one to be like VS Code. So this one on Linux or Windows should be Control up or down if you're in VS Code. Um, and if you're on a Mac, it might be Command up and down. I'm not sure, but it's called line move or move line with cursor maybe. You can look it up for your given operating system and text editor, things like that. So basically, I just take the thing that I'm appending and I put it in the front. Then I'm going to take the loop head, put that after that. Now, given that we have like single condition style control flow, I know that this style of control flow has to go at the very end of the comprehension, and then I'll just clean up everything that's left over. Great, so I've got this. Now notice I'm making this list variable and then immediately returning it, the length of it. So I actually don't even need the list variable. I can just pop that into len and return it directly, and this should also work, and that does. Cool. I think that ran quite a bit faster too. So let's try that again. Great. And I'm going to hit submit. And then you'll have a opportunity to look through other people's code and see how they did things. Wow, wow, this is quite the thing. For beginners. Okay. All right. We've got benchmarks on all these. It's slow, but it's slow because it uses is instance. Ah, I hate is instance. Um, no. Let's see. Uh, well, this one looks like the fastest. Uh, even don't even don't need return true, because compre comprison comprehension presumably operator will return boolean. Oh, comparison. Oh, that's just me being dyslexic. Um, okay, interesting. This looks kind of similar to what I did, but hmm, hmm, interesting. Oh, that is kind of cool. So this is taking the sum of a bunch of booleans, of a list of booleans. A true will be treated as a 1, and a false will be treated as a 0. So um, this is a true or false value for x in range 1 to n plus 1. So that's basically the same thing. This is the same, more or less the same comprehension that I did, or condition I meant right here. But they just did it a little bit differently and then took the sum. So yeah, so you can look through and just find other solutions. Sometimes you'll see a different way of thinking about the problem that maybe you didn't think of before. Sometimes you'll see your own solution somewhere in there. So yeah.